Smart Solutions. Add-on desired.
Hello everyone, this is Sudhakar, working as a mathematics lecturer in Edward Solutions. Today we are going to discuss intermediate first year topic mathematics 1A functions. Okay, here we are taking now long answer questions. So first question number 1, let F is mapping from A to B and G is mapping from B to C be bisections, then show that G circle F is a bisection. G circle F is a bisection. This is the theorem. So for that, first we need to take the definition of bisection. What do you mean by bisection? A bisection in the sense a function satisfies 1 and onto properties. 1 and onto properties. So we'll see now. First, F is mapping from, right. Now starting onwards I am telling. So now here coming to the question number 1. What is question number 1? Let F is mapping from A to B and G is mapping from B to C, right? Be bisections, then show that G circle F from A to C is a bisection. That is the theorem we are going to prove now. So here in this, first we need to know definition of bisection. Definition of bisection, right? A function said to be, or a function F is mapping from A to B, said to be a bisection if it satisfies 1 and onto properties. A function said to be a bisection. A function said to be a bisection if it satisfies one and onto conditions or 1 and onto properties. A function is said to be bisection if it satisfies 1 and onto. So here first I am taking F is mapping from A to B be a bisection. Okay. First condition number 1. Let F is mapping from A to B be a bisection. Okay. So what is the meaning of here bisection? 1 and onto. Condition number 1. Let there exist A1 comma A2 belongs to A. In this condition, A is domain, B is codomain. So we need to take domain elements here. Okay. There exists A1 comma A2 belongs to A, right? Such that F of A1 is equal to F of A2 if and only if A1 is equal to A2. A1 is equal to, this is what? 1. This is 1. Okay? 1 condition. Next we need to take onto. How to take onto? Condition number 2. Or here you can take in general. Right. Next. Point number 2. There exists an element A belongs to A such that F of A is equal to B for all B belongs to B, then therefore this is onto. This is what? Onto. Same thing for we need to take G function. Okay. So here I am taking G is mapping from where to where? B to C. G is mapping from B to C, right? Be a bisection. Be a bisection. This is the condition. So in this one I am taking first point. There exists B1 comma B2 belongs to B such that G of B1 is equal to G of B2 if and only if B1 is equal to B2. This is 1. This is what? 1, 1. Okay. Next, condition number 2 in this. This is what? Condition number 1. Next, condition number 2. There exists an element to B belongs to B such that G of B is equal to C for all C belongs to C. This is what? Onto. This is what? Onto. Right? So here F is mapping from A to B, 1, 1 and onto, that is bijection. Next, G is mapping from B to C. G is mapping from B to C. Be a bijection. It satisfies 1, 1 and onto. Okay. So these two functions are bijection. So here we need to combine these two functions in G circle F. That one we are naming it as what? Composition of two functions. What it is? Composition of two functions. So here now I am taking, right. So here I am taking now F is mapping from A to B and G is mapping from B to C are two bijective functions. Are two bijective functions. Okay. So now I am taking G circle F. G circle F. So if you remove this G, will F starts from A to B. So if you remove this B, F is from A to B. Next to G introduced. G introduced. G is from where to where? B to C. According to the composite function definition, B is removed. According to the composite function definition, B is removed because a function is having domain and codomain only, right? So this can be written as G circle F from A to C. This is what? Composite function. In the sense, composition of two functions here I am writing. Okay, this is what? Composite function. Okay, so now to prove G circle F from A to C 1, 1. This one we are going to prove now. This one we are going to prove now. So for that one, G circle F, what is our domain? A is our domain. What is our domain? A is our domain. So I am taking G circle F from A to C. G circle F from A to C. So here domain I am taking. There exists A1 comma A2 belongs to capital A, domain elements, right? Such that G circle F of A1 is equal to G circle F of A2. Okay. So if and only if, according to the composite function, I am splitting G of F of A1, okay, is equal to G of F of A2. Since G is 1, 1, since G is 1, 1, so condition will come like this: F of A1 is equals to F of A2. Since G is 1, 1, internal values only here we need to take. Okay, F of A1 is equal to F of A2. Next, since F is 1, 1, since F is 1, 1, in this condition what will come? A1 is equal to A2. A1 is equal to A2. Therefore, where we started? We started from G circle F of A1 is equal to G circle F of A2. Where we reached? A1 is equal to A2. A1 is equal to A2. This indicates what? G circle F from A to C is 1, 1. Therefore, G circle F from A to C is 1, 1. Okay. So 1 condition is verified. Now to prove G circle F from A to C is onto. That one we need to prove now. Okay. So to prove G circle F from A to C is onto. This one we need to prove now. G circle F from A to C is what? Onto. Okay. For that one, I am taking G circle F from A to C. So in this one, who is our domain? First place is domain, second place is codomain. I am taking domain elements. Okay. There exists an element A belongs to A such that G circle F of A is equals to G of F of A. G of F of A, right? Since F of A is equals to B, because it is onto, no? F of A is equal to B. So this is equal to G of B. Since G of B is equal to C, onto condition in G. So this is equal to C. For all C is there in codomain C. Therefore, G circle F of A is equal to C. Therefore, it is onto. Domain element has mapped to codomain. That is the definition of onto. So, therefore, it is onto. Okay. Therefore, we can conclude that final. So, hence G circle F from A to C is a bisection. This is the theorem proof. Okay. Let again explain once. Again I will explain this theorem once because this is the most important theorem. Okay. Right. So look at here. F is mapping from A to B and G is mapping from B to C are two bijective functions. Then he is asking to prove G circle F from A to C is also a bisection. This one he is asking to prove. So for that one, first we need to know the bijective function. Bijective function in the sense a function said to be bisection if it satisfies one and onto conditions or one and onto properties. So here I am taking a function. F is mapping from A to B. Be a bisection, that is there in the given statement. So bisection, what is bisection? 1 and onto. First I am taking 1 condition. There exists A1 comma A2 belongs to A. Where we are taking A1 comma A2 are the elements in our domain set. A1 comma A2 are the elements in our domain set, right? Such that F of A1 is equal to F of A2. F is the function taking domain elements to the codomain in general. That is the definition of the function. So here F of A1 is equal to F of A2. I am taking if and only if A1 is equal to, this indicates that is the function 1 or that function is 1 Next to onto. There exists an element A belongs to A, right? Such that F of A is equal to B for all B belongs to B. This indicates what? Onto in function F from A to B. Next coming same G function from B to C. Be a bisection. So in this one domain is what? Capital B. In that I am taking B1 comma B2 are the elements. In that one I am taking B1 comma B2 are the elements such that G of B1 is equal to G of B2. This indicates what? If and only if B1 is equal to B2. Indicates 1 function in G. Okay. Next to second one I am taking. B belongs to B. There exists an element B belongs to B domain element such that G of B is mapping to C. This is what for all C belongs to C. Domain element has mapped to codomain, that is the definition of onto. That only here I have taken. So now I am clubbing F function and G function in one function. That one by taking composite function. Composite in the sense composition of two functions or we are composition of clubbing functions, we are making it as composite. So F is mapping from A to B be a function and G is mapping from B to C be a function. We are clubbing both functions in one function. That is what? Composite function. Okay, right. So here now I am taking F is mapping from A to B and G is mapping from B to C are two bijective functions. Okay, now G circle F. from A to B and B to C. So B is the mediator value, but here we don't want to consider, right? So we need to take function domain to codomain only. So domain is A, codomain is C. This indicates what? G circle from A to C. This is what? Composite function. So now to prove G circle F from A to C is 1, 1. Okay. For that one, I am taking there exists an elements A1 comma A2 belongs to A such that which function is to be proved 1, 1? G circle F from A to C. Which function is to prove 1, 1? G circle F from A to C. For that one I am taking G circle F of A1 is equal to G circle F of A2. If and only if I am splitting G of F of A1 is equal to G of F of A2. We can cancel G's, or by the definition of 1, 1 of G. So F of A1 is equal to F of A2. In this sense, the internal values only here we are taking, or you can cancel, no problem. Next to if and only if A1 is equal to A2. Because this is the definition of 1, 1 for F. Right? Now, we can conclude that G circle F from A to C is what? 1, 1. G circle F from A to C is what? 1, 1. Next, to prove G circle F from A to C is onto. To prove G circle F from A to C is what? Onto. For that one, I am taking there exists an element A belongs to a domain element such that G circle F of A is equal to G of F of A. By the definition of onto function, F of A is equal to B. Here, F of A value we are replacing it as B. Next, by the definition of onto function in G, G of B value goes to C. Therefore, G of B is equal to C. For all, C belongs to C. Where is C? C is there in element. C is an element in codomain. So hence we can conclude that G circle F of A is equal to C. Domain element has mapped to codomain, or domain is mapped to codomain, right? So we can say that is onto. That is what? Onto. Hence we can say G circle F from A to C is what? Bisection. Bisection sense it satisfied 1, 1. At the same time it satisfied onto. Therefore it is what? Bisection. Okay na? Right. Go for the next theorem.
Add-on solutions. Add-on desired.